In this video, I'm going to talk about our work of two-dimensional touch pointing models. This work is the collaborations between our lab and Shumin Zhai from Google. The most widely known touch pointing model is Fitts law. Here are the most widely known 2D version of Fitts law. Euclidean model proposed by Akaike and Zhai in 2003, and the smaller of model proposed by Mackenzie and Boxon in 1992. They work well in mouse and pen-based pointing but face some problem in touch-based pointing. For example, both models predicted that if the target width, height, and distance are proportionally reduced, the pointing time should remain the same. But for touch pointing, this assumption is violated. Let's take typing on the soft keyboard on the smartphone and smartwatch as an example. Typing on the smartphone is much faster than typing on the smartwatch. However, this is against what Fitts law suggests. Fitts law suggests that typing speed should remain the same from phone to watch because the size of a key and distance between keys are proportionally reduced. We refer to this phenomenon as the violation of scale independence. This cannot be explained by the existing 2D Fitts law. Finger Fitts law was proposed to account for ambiguity for finger touch for 1D touch pointing. The basic idea is that it introduced the component presented by sigma A that caused the ambiguity by finger touch. And this part of the ambiguity is independent from the task, so it should be removed from the Fitts law formula that explains the speed-accuracy trade-off of the motor system. The finger Fitts law has been shown better performance in touch pointing, compared with traditional Fitts law. In this paper, we derived the 2D finger Fitts law by introducing the idea of accounting the finger ambiguity to the two most widely used 2D Fitts law, Euclidean form and smaller of model. The basic idea of our refinement is that we subtract the component from the target width that represent the ambiguity of finger touch. For these two models, we also subtracted the ambiguity from the target width and height. This leads to three possible model candidates of 2D finger Fitts law. The first model is that the C square is subtracted from both W and H square as the same ambiguity. The second one is that we subtract different ambiguity from W and H, and for smaller of model, we subtract the C square from the minimum of the width and height. To evaluate the model candidates, we conduct a rectangular target acquisition experiment with different combinations of distance, x, and y length, which refers to the nominal width and height of the target. We recruited 18 participants in total, 63 combinations, and 16 pointing directions were considered. We evaluated 5 model candidates in Euclidean and smaller of form with the observations, 2 Fitts law models, and 3 finger Fitts law. Our results show that in smaller of formulation, smaller of finger Fitts law has better performance than the smaller of Fitts law model. In 3 metrics we measured: R-square value, leave one out root mean square, and widely adopted information criteria, WAIC. Our results also show that Euclidean finger Fitts law outperforms Euclidean Fitts law. These two finger Fitts law models perform better in R-square value, leave one out cross validation, and also in WAIC. The Euclidean finger Fitts law, which considers W and H have the same ambiguity, performs almost identical to the one that considers ambiguity separately in W and H direction. We conclude that since the Euclidean finger Fitts simplified model has less parameter, and this is the best model we have. The 2D finger Fitts law also explains the violations of scale independence. These two models show that if we proportionally reduce the width and the distance in the task, it will increase the value of the index of difficulty. This is because the C-square value is not cancelled out if you reduce A and W proportionally. In this research, we derived 2 models for modeling 2D touch pointing. We call them 2D finger Fitts law. Our research expands the paradigm of finger Fitts law from 1D to 2D. They have better model fitting performance than Fitts law and explain the violations of scale independence in touch pointing.